All right, let's talk about graphing. So the first thing we got to discuss is the rectangular coordinate system. So here's that. So the system is made up of the x-axis, which is the horizontal line. Positive numbers will be on the right side, so these will be the positive end, this is the negative end. For the y-axis, the positive numbers are vertical, going up, and the negative numbers are down vertically. So these are going to intersect at right angles. This point where they both intersect is called the origin, which is 0, 0. And this creates 4 quadrants. Generally, they're labeled or numbered 1, 2, 3, 4. I don't think that shows up much in the homework, so I won't worry about that. And when we write points, when we plot a point or ordered pair, it's going to be of the form x, y. So whatever the x coordinate is will be labeled first and then y coordinate. So let's look at a couple of these examples. So here are some points that we're just going to plot. The first one, minus 2, 4, of course, what that means is the x coordinate is negative 2, the y coordinate is 4, so minus 1, minus 2, and we're going to go up 4. 1, 2, 3, 4. And so, oops, make it larger here. So this is the point minus 2, 4. And we can label that point A. All right, let's do another one. 2 minus 4, I just wanted to show you that these are different. So I'm going to go 2 in the x direction and then minus 4 in the y direction. So this is the point B. And then lastly, point C is 3, 0. So I'll go 3 in the x direction, 0 in the y direction. So this point right here on the x-axis is C. All right. In fact, this section isn't very long. We're just kind of getting the introduction of this material. We'll do more graphing in the next section. All right, so a relationship between two quantities can sometimes be expressed as an equation in two variables. And a solution of an equation of two variables is an ordered pair that makes it true if we plug in or substitute x for the x coordinate and y for the y coordinate. So let's look at a couple of examples. So for the first example, we have this equation, this line, y equals 2 plus 3x, and we want to state whether 2, 8 is a solution. So what that means is I'm going to substitute x equals 2 in for 2 or x, and then 8 in for y. A lot of times I like to use parentheses when I do my first substitution. All right, so what we're doing here is we're checking to see if these two sides of the equation are true. So I always do like a little question mark. Is this true? If it's true, then it is a solution. If it's not true, then it's not a solution. And I don't need to do any type of weird algebra here. I just need to say, like, clean up the left. 8 is just 8. And then over here, this is 2 plus 6. 2 plus 6 is 8. So here I'm still asking, are they the same? Here we know they're the same. This is a true statement. So 2, 8 is a solution to y equals 2 plus 3x. In the past, I would do one example and move on, and then I decided, well, that's what it looks like if it is a true statement. Let me show you what it is, what it looks like if it's not a true statement. So we're going to work it the same way. This one's not going to work out, but I want you to see what the difference is. So if it is a solution, that means that that ordered pair lies on the line. If we are testing this point and it doesn't create a true statement, then that means that point doesn't lie on the line. So let's just check that out. So minus 3 is equal to 1 minus 3 times 1. So minus 3 is just minus 3. So minus 3 equals 1. Minus 3 times 1 is minus 3. Still asking ourselves, are these equal? Again, we're not doing any type of weird algebra, but 1 minus 3 is minus 2. So is it true that minus 3 is equal to minus 2? No, right? Minus 3 is not equal to minus 2. So this right here is not true. So 1 minus 3 is not a solution to to the equation y equals 1 minus 3x. Okay. All right, so that's the difference. And then the last thing we would discuss in this section is the graph of an equation in two variables, which is the set of all points who satisfy the equation. So, for example, 2, 8 here satisfied this equation, but the graph of this line would be every single point that satisfies this equation. If there are lines that we're drawing, then we usually only need to plot 2 or 3 points, and then from there connect the points, and that makes the line, which shows all the points that satisfy it. Now, in this chapter, they will specify how they want us to graph, which is using intercepts. So rather than doing an example of graphing in this section, I'm going to wait till the next video and then show you how to graph using intercepts, because as you go through this chapter, that's the way they want you to graph. Not using any other form, but using specifically intercepts.